All right, so hello and welcome to the second fireside chat on Kubernetes operational maturity as it pertains to the evolution of Ingress to Gateway API. That's this episode. As the industry shifts away from legacy Ingress controls, the transition to Gateway API is on everybody's radar, as we all know. Beyond the hype, what does this migration actually look like for enterprise teams, and how do we ensure stability and scalability during the process? To walk us through some challenges and insights, I have recruited Sebastian, Director of Solutions Engineering at Tigera, who will share his experience in helping organizations navigate some of these architectural shifts. So first off, it's easy to talk about moving to Gateway API. It looks very clean. It seems like the most sensible future-proof choice. Now that the ingress-nginx controller retirement has put migration on everybody's radar, but realistically, what does it look like out there? Are people adopting or planning to adopt Gateway API, and what are some of the blockers that you see out there?
Well, I mean, yeah, the honest picture is big gap between intent and reality. There's no doubt that everybody knows that the community ingress-nginx controller hit end of life in March of this year. And there's no doubt that it was kind of widely used and in front of many clusters, so it's not a niche concern. But as I kind of talk to account, most teams are still at assessment stage and have not migrated yet. There's a lot of planning happening, but a few of them kind of finished the migration. And the thing that slows them down usually isn't just the Gateway API spec, it's mostly the organization. Ingress in most enterprise was built across multiple BUs over the years. And the person who's actually responsible for keeping the ingress up is almost never the person who actually configure the routes on it. So step one isn't technical, it's figuring out, who owns what and agreeing on, how to move forward. And then you have kind of technical blockers, because you do have some. And the real blockers are usually around nginx specific annotation, config maps, and snippets that nobody documents. And there is kind of a skill gap on Gateway API and Envoy. So yeah, I rarely have the question of, should we move to Gateway API? Everybody agrees they should. But the question is, who owns Ingress and how do you move it without an outage? And the team that answered that question first are the one who actually move forward.
Like, what are some of the most common architectural anti-patterns that you have seen out there working with diverse deployments with customers?
Right. I suppose the pattern I see again and again is a single shared ingress controller for the whole cluster or the whole org, where everything is funneled through. And every team writes Ingress objects, and all of them are combined into that big, nginx conf file in the one controller. And it looks efficient, but it's kind of one big, ticking bomb. So two things make it worse. First, because the Ingress spec is so minimal, anything interesting like rewrites, authorization, rate limiting, sometimes you have snippet of Lua, ends up being jammed into annotation. So your routing logic and your business logic are living in the same place. And then the second issue is that there is no blast radius thinking. So there's no separation between platform-owned infrastructure and app-owned route. No admission validation, no stage rollout. So the anti-pattern isn't they used nginx, is that the one config, one controller, and one blast radius were doing the job of an entire traffic management architecture.
So you dealt with a customer situation where a single bad Ingress resource triggered like a cluster-wide failure. Does this kind of, is this one of the things that can happen when you implement such anti-patterns?
Yeah, so basically the nginx controller, which is all ingress resources, and any change will generate one big nginx conf, and it triggers a reload of the data plane. Under normal churn, that's fine. But if you introduce problematic resource, like a bad rewrite regex, or a snippet that's not working, or something that bloats or break the config generation, then you get reload churn. And failed reload or reload storms, then you get worker trashing, and the connections are getting reset. And critically, that damage isn't scoped to the team that made the mistake, but it hits every host name that the Ingress controller serves. So what that incident actually in that case really revealed is three problem. First is a shared control plane is shared by radius, and you've coupled the reliability with unrelated teams. Second is config, gRPC, and data plane are coupled, so reloads are not free, and they're not saved by default. And then the third issue is this architecture flexibility is global and unvalidated. And the same property that makes it operationally fragile is what made the Ingress nightmare possible. And that, I suppose that's another reason why this matters with migration. Envoy was designed with an API first. Config is pushed to the data plane dynamically over XDS. So a root change is incremental update and not a config generation and reload.
How do you assess if teams are ready for this migration and what their state of operational maturity is?
Right. I suppose you have, let's say we have maybe four. You have a beginner, you have intermediate, advanced, and you have kind of super optimized. And yeah, so I suppose that would be kind of the four kind of categories. Difference between intermediate and advanced. But I suppose again, intermediate would be a team that has an ingress controller working reliably, but it's a single shared controller. Operation owns it end to end. Changes are manual. Annotations are doing the heavy lifting. Observability is basic, and it's almost all plain HTTP. So that would be my kind of definition of intermediate. And advanced would be more towards they bridge the gap and they move towards governance. So platform owns the gateway, and then the app team own their own routes, and all the changes go through a GitOps process. And there's progressive deliveries, whether it's canary deployment or blue-green or with weights. So I suppose that would be how I do the difference between each team. To assess readiness for the migration specifically, what I would ask is, do you have an inventory of every ingress resources and which are internet facing? And the other one would be, do you actually know what's inside your annotation and snippet? Can you run two controllers in parallel? And I suppose like the one that is kind of the critical one is like, who owns this? And if they can't answer the ownership question, they're not ready to migrate. They're just ready to have the ownership conversation first, because we can't migrate anything we don't know who owns it. So yeah, intermediate team keeps Ingress running. Advanced team have made it governable. So the migration is really the moment you decide which one you want to be. So yeah, that's what I assess for, not for just API trivia.
So I think we touched on this a little bit earlier, but what is the driving force behind teams adopting role-based ownership when it comes to traffic routing? What are some of the things that tip the balance in favor of Gateway API with the separation of concerns?
Yeah, the driver is organizational reality finally colliding with the tooling. In any real enterprise, the platform team owns infrastructure, the load balancer, the gateway, the listeners, TLS certificates, and the application teams own their own routes. Ingress is conflated all of that into one resource with a lot of annotation. So to ship a routing change, an app developer either needed broad access to a shared cluster surface or had to file a ticket and wait for the platform team. And you get bottleneck and risk at the same time, which is, I suppose the worst of both. Because of the way the Gateway API is designed around roles, the infrastructure provider owns the gateway class, and the cluster or platform operator owns the gateway, and the application developer owns the HTTP route. With RBAC and cross namespace references to make the boundaries real. So Ingress made you choose between a bottleneck and a security risk when Gateway API lets platform own the front door and the developer own their own room, which is how the org, should have been structured all along.
Makes sense. So actually migrating, so let's talk a little bit about migration. The challenges of migrating to Gateway API are many. What is the one problem no one expects, and what is the one problem that everyone fears and prepares for but ends up not being an issue?
The one nobody expect, you don't migrate configuration. Basically, you rediscover undocumented behavior. So, the obvious, like the obvious route, and they work fine. And the tooling around it has been, pretty good. Actually, we kind of took the Ingress to Gateway tooling and added a bunch of annotation to it, so it makes it, a lot easier. So you have maybe, I can't remember how many we covered, but maybe 60 or more. So that makes the migration of those very easy. But the issue is everything that's not, in the 60 annotation that can be converted in by the tooling. And try to kind of remember what it does and understand basically who wrote the regex that was done ages back, or what a snippet of Lua is doing, and nobody remembers who added it.
Right.
There's no design doc, no nothing.
So you basically have to go back in there and do some forensic, like reverse engineering of these rules. That's, I never even thought but that makes complete sense. It does.
Yeah, and when you look at Lua and regexes, it can be quite a headache to kind of understand what was the intended behavior by writing those rules. And they work, so you can't even question whether
it works.
Some of them might look funny, and it's just like, is that really what it's meant?
Yeah.
But it's been working for years, so yeah. So
And I bet you wonder what's going to break, right? Like
if
you don't port that rule over, like what mystery thing is going to not work now?
Yeah, it's like downtime at cutover. The big outage, and what's going to break, and and the fear of that. But to be honest, it's like any migration, and it's not specific to nginx. But any migration is like 80% of it is in the preparation, and then if you did your homework properly, when comes time to cut over, usually it's good.
So when Ingress was first introduced, the assumption that traffic would be mostly HTTP was a reasonable assumption. What does the protocol landscape look like now? How common is it to have things like gRPC, and what are the features that were once considered advanced are now kind of the norm, especially with the AI workloads coming in and needing.
Yeah, well, I suppose gRPC is now mainstream for service to service. And Gateway API made gRPC route stable. GA resources back in 1.1. So it's a first-class citizen now, not a workaround. Obviously, HTTP2 is everywhere. HTTP3 and QUIC arriving, WebSockets, and a real need for raw TCP, UDP, and TLS pass-through for database, blockers, and streaming. MTLS between services has gone from security team wish list to baseline expectation. So I suppose that's another new thing. And the features we used to call advanced are just now kind of table stakes. Header and method-based routing, traffic splitting, and waiting for like canary deployment or blue-green. Traffic mirroring for testing, retries.
Was that a big thing out there? Everybody wants better traffic control.
Yeah, and definitely, yeah, for sure. You want to be able to kind of shift your traffic and see whether it breaks, it doesn't. See if the application, the backend are able to handle it, and so on and so forth.
So you've
So yeah,
seen both. That makes sense. So if people want any of that advanced traffic control, it is like kind of like moving to Gateway API is not a nice to have. It's kind of a must have right now. So have you seen instances where people just swapped in another nginx controller or the same kind of like another Ingress controller? What's the conversation earlier on that determines whether the customer kind of ends up with a real upgrade or a relatable status quo? So what makes them just want to swap things out and what makes them want to migrate to Gateway API?
Well, if the opening question is how do I convert my annotation one-to-one and chant as little as possible, this is going to be a lift and shift, and they all posture onto the new controller. And they're not really going to take advantage of the new world. And it's been that's a kind of relabeled status quo. They did the work, but they didn't improve anything. The migration that becomes real upgrade starts somewhere else is when again you take that approach where you decide that who should own the routing. How do we isolate teams from each other and all these kind of RBAC questions. Do you want progressive delivery as a default? What's the security posture at the edge, WAF or MTLS? What do we want to actually see? And so the people kind of asking those questions are the one who are most likely gonna get the most out of the migration and the gateway API specs. So if the first question is about annotation, you'll get a new logo or a new gateway API, but you'll get the same problem. But if the first question is about ownership, then you'll get the upgrade that you can investing time for.
Yep. So that makes sense. And basically, and Microsoft managed Nginx support ends in November. SUSE is giving Nginx another 12 months. Red Hat and Canonical are pushing teams towards Gateway API as well. So it seems like that's the future. So from your vantage point across many customer conversations, how should architects think about prioritizing migration work over the next 6 to 12 months?
I suppose I would be looking at do you have anything internet facing still on community ingress nginx? And that's not a future risk, that's live and patch exposure today, past end of life. So I would be like, that's the first thing you need to move now. Then the hard cliff is like, AKS managed nginx users have a firm, you said November 26th date, is it? So, I mean, that's the deadline. So, get a plan into place because that's what you have until to kind of get moving onto something more reliable. And then if you're on supported LTS or long-term support, you have breathing room. Use it to migrate properly, but not to do nothing. Being supported doesn't mean migrated, and the fact that you have more time doesn't mean that you don't have to do it. So use that time wisely. And for every of those cases, it's the same sequence every time. Do the inventory, assess your annotation, with migration tooling, pick your target, stand the new gateway up, cut over the lower three services first, use weighted steps, and then rinse and repeat.
That makes sense. All right. I think our reference architecture lists Ingress as one of the key areas of pursuing Kubernetes operational maturity. So just to sum up, and your experience, what is like the number one top reason that organizations should consider moving from Ingress to Gateway API? And I know we've talked about several of them, but what's the like the top number one, like you got to do this reason that you've seen out there?
Uh, well, I mean, the main reason is end of life and you're exposed. So the main reason is you don't have support, and it's the door into your cluster. So you're exposed. The main reason is you need to make sure that your cluster is safe, I suppose would be the first one.
That makes sense. So it's not even the extra features, the traffic management. It's just basically you
Oh, that's
have to
of
do this or
course
you're
you want all of
insecure.
that. But first and foremost, just like you have a massive security gap. And before getting any of the bells and whistles that the Gateway API gives you, just make sure that, environment is safe and secure. Moreover, in this age of AI, where, being able to exploit non-maintained software is easier than ever.
Awesome. Well, thank you for walking me through the nuances of the transition to Gateway API. And I certainly learned a few things that, I kind of knew in the back of my mind, but I wasn't thinking about. And so, like you've covered a lot more than usually people talk about when they talk about moving to Gateway API. So is there anything you'd like to add? Any final words to teams looking to do this thing? Any words of wisdom or advice?
Uh, yeah, just inventory, assess, decide ownership, do that this week. The migration is a big, is as a big part, preparing for what you're gonna do. So just prepare today. That's, I suppose, that would be the closing word.
All right, that's great. Okay, so thank you. And everyone, thanks for watching. Join us next time when we discuss the next pillar of Kubernetes operational maturity. In the meantime, go to www.tigera.io and look up Ingress Gateway to learn more. And thanks for watching.